NASA's been on the hunt for a faster path back to the moon. Interestingly, SpaceX claims they already have a plan, though for now it's mostly behind closed doors. So naturally, today we're digging in to uncover what that plan could be by exploring the most likely options. Let's get right into it. Recently, a NASA representative confirmed that the agency received and is currently reviewing proposals from both SpaceX and Blue Origin aimed at speeding up HLS production. They added, once the government shutdown concludes, NASA will release a request for information to the wider aerospace sector for additional concepts. A panel of NASA's leading experts is being assembled to assess each submission and decide the most effective strategy to win the second space race, given the urgent threats to peace and transparency on the lunar surface. As for SpaceX, the company informed NASA that it's pitching a simplified mission designed to get astronauts back to the moon faster. This update followed public criticism from Sean Duffy over repeated delays. In a blog post published Thursday, Elon Musk's aerospace and defense company wrote, "We've proposed and are actively evaluating a streamlined mission, architecture, and operational concept that we believe will enable a quicker return to the moon while enhancing crew safety." So first, let's look at what Starship is currently meant to do under the existing plan. That way, we can see why the mission might need simplifying and what SpaceX could realistically change to make it better. Under NASA's Artemis framework, the process starts with launching the lunar version of Starship into low Earth orbit. Then, multiple tanker Starships rendezvous and refuel it in space. After fueling, the lunar Starship ignites again to exit Earth orbit and travel toward the Earth-Moon transfer point, where the moon's gravity takes control. Next, Starship uses its engines to enter what's known as a near rectilinear halo orbit around the moon, essentially a stable parking orbit where it can wait. Meanwhile, NASA launches the SLS rocket with the Orion capsule carrying 4 astronauts. Orion travels to the moon, enters the same orbit, and docks with Starship. 2 astronauts then move into Starship, descend to the lunar surface, carry out their mission, and later return to orbit to rejoin Orion. Once everyone's back aboard Orion, it fires its engines for the journey home, leaving an empty lunar Starship drifting in that same halo orbit. That's a lot of moving parts. Holy smoke. That's a complicated chain of steps. Honestly, it's surprising it took this long for NASA to request a simpler mission layout. Elon Musk once mentioned on X that Starship might eventually handle the entire lunar journey itself. That could mean SpaceX is considering taking on the full mission independently. No Orion, no SLS, just Starship. But that's a huge challenge. It's hard to imagine Starship evolving quickly enough to manage every stage of the moon mission solo in such a short time frame. So for now, a smarter interim move might be bringing another SpaceX vehicle into the equation. Something like Crew Dragon. Of course, flying beyond low Earth orbit would demand some serious, though still possible, upgrades to Dragon. In orbital mechanics, mission design comes down to energy, what engineers call delta V. If NASA ditches SLS and Orion, then the replacement system needs to cover all their roles. That means enough delta V to reach lunar orbit and return, plus the ability to withstand re-entry speeds from the moon, which are brutal. Lunar re-entry generates over twice the heat and energy of coming home from low Earth orbit. So Dragon's heat shield would need a massive upgrade. Its current PKX shield might have to be reinforced or swapped out entirely for something stronger. Then there's life support. The spacecraft must keep the crew alive and comfortable for the entire trip. Reports suggest Dragon can currently sustain astronauts for around 7 to 10 days. Not quite ideal for a full lunar journey. For comparison, Apollo could handle 14 days, Orion up to 21, and most Apollo flights lasted between 8 and 12.5. So technically, Dragon could just make it, but with little margin for error. To pull it off, the ship's life support and consumables, oxygen, water, and CO2 scrubbers would need upgrades. That adds weight and shrinks cabin space. Dragon's cabin volume sits around 9.3 cubic meters, smaller than Orion's 20, but bigger than Apollo's 6.2. Tight, yes, but doable for a short lunar run. So overall, if SpaceX can solve the Delta V and endurance issues, Crew Dragon might actually be a workable short-term option for getting humans back to the moon. Here's how that could look in practice. SpaceX launches a Crew Dragon into orbit, then either nests it inside the lunar Starship or attaches it to the front. Once Starship reaches lunar orbit, it drops off Dragon. After the surface expedition, the astronauts board Dragon for the trip home. This setup comes with a big advantage. Dragon only needs enough Delta V to leave lunar orbit, and its life support only has to last for the journey back to Earth. If SpaceX could repurpose Dragon's Super Draco abort motors for the main burns, the current model might actually handle the job with only minimal modifications. Of course, Starship itself would need some tweaks too, either to carry Dragon internally or handle the added stress of mounting it on the nose during launch and flight. Another straightforward approach could be to launch the crew aboard Dragon, just like current missions. Once in low Earth orbit, astronauts could transfer into the human landing version of Starship. At that point, they might as well ride Starship all the way. It's already headed to the moon. From there, Starship would fly straight to the surface, skipping NASA's current Artemis plan that involves rendezvousing with a space station or docking in a near rectilinear halo orbit. After completing surface operations, Starship would lift back into a relatively low lunar orbit, a move that could reduce how many in-space refueling flights are needed. That, in turn, would free up other starships for practical uses, like deploying Starlink satellites or hauling payloads. Once in orbit, Starship could dock with a return vehicle, a modified Crew Dragon that launched earlier on a Falcon Heavy. Because that Falcon Heavy would be uncrewed, it wouldn't need human rating or a launch abort system. Falcon Heavy already has the performance to send Dragon on a trans-lunar trajectory. Then, Dragon's hypergolic engines, including the Super Dracos in its trunk, could handle the rest, circularizing into low lunar orbit, docking with Starship, and performing the trans-Earth injection burn for the return home. In this setup, life support only needs to keep 2 astronauts alive for a few days, well within Dragon's capabilities. It's a clean, affordable concept that relies mostly on hardware SpaceX already has, while removing a ton of complexity from NASA's current Artemis structure. Now, what if Elon really wants Starship to do everything on its own? No Dragon, no Orion, no SLS. Could that actually work? If the plan is to rely purely on Starship, the key question becomes, can the lunar variant make it all the way back home? Unfortunately, 2 big problems stand in the way. First, the lunar Starship doesn't have enough Delta V, meaning it lacks the energy needed to leave lunar orbit and return to Earth. And even if it did, there's an even bigger issue. It doesn't have a heat shield or control fins. That means it couldn't survive re-entry through Earth's atmosphere. That's a deal breaker. But there might be a workaround. Imagine sending a fully shielded Earth-return Starship into lunar orbit. One that's been refueled just enough to get there, pick up the crew, and fly them safely back home. That could solve both problems, assuming Starship's heat shield can actually withstand the intense re-entry speeds from a lunar return, which are far higher than coming back from low Earth orbit. If it can, then the concept is straightforward. The catch? You'd still need a new lunar Starship for every single mission. The good news is that this plan uses Starship mostly as is, no radical redesigns. But it does mean astronauts would have to launch and re-enter inside Starship itself, which adds risk and operational challenges. Looking further ahead, once Starship reaches version 4 or beyond, with engines powerful enough to produce over 3 times the thrust of Saturn V, then a fully independent Starship lunar mission could absolutely be possible. At that point, it might only take a couple of in-space refueling stops to complete the round trip. But for now, Starship isn't quite there yet. It's still too early for the vehicle to manage a complete moon mission solo. So far, we've focused mostly on SpaceX and its push for a streamlined lunar architecture. But what about Blue Origin? They've got a plan too. Blue Origin has been working on its own lunar lander for NASA and has already received around $835 million in funding since the contract began back in 2023. The company's flagship system is the Blue Moon Mark II, a much larger lander designed to carry astronauts to the lunar surface. Realistically, though, it won't be ready until sometime in the 2030s. Just like Starship, the Mark II will require multiple refueling missions to complete a single trip. As part of its contract, Blue Origin is also collaborating closely with NASA on the crew cabin for the Mark II. But before that becomes operational, they've got another vehicle nearly ready to go, the Blue Moon Mark I. This first model, the Mark I, is set for a Pathfinder mission in early 2026. When it lands, it'll become the largest vehicle ever to touch down on the moon. However, it's not meant for humans. It's a cargo-only lander. Its biggest advantage is simplicity. The Mark I doesn't need any in-space refueling, which drastically streamlines the operation. The downside, of course, is that it can't carry astronauts. At least not yet. To human rate the Mark I, Blue Origin would need major modifications, especially for life support and crew accommodations. That said, it's not impossible. The Mark I is actually larger than the Apollo lunar module, so with proper life support, it could theoretically handle a crewed landing just like Apollo did. But here's where things get tricky. Unlike Apollo, which didn't have to rendezvous in a near rectilinear halo orbit, Blue Origin's human landing architecture will, and that maneuver burns a lot of delta V. So how could Blue Origin make that work? They haven't revealed exact mission details yet, but they're still refining the architecture. It's possible they might adopt a setup similar to SpaceX's, using multiple vehicles to complete one mission. For example, several Mark I landers could operate together, one or more to carry astronauts to the lunar surface, and others to help them ascend and rendezvous with Orion for the trip home. Now the big question, who's going to get there first, SpaceX or Blue Origin? Honestly, if Blue Origin can successfully modify and human rate their Blue Moon lander, they might technically reach the surface first. Their close partnership with NASA under the Artemis program gives them a real shot, especially if they can streamline testing and development. But being first isn't the same as being better. Sustainability and scalability are what really matter in the long run. SpaceX's Starship, for all its engineering and regulatory headaches, is built around a far bigger vision. Its fully reusable design, enormous payload capacity, and in-orbit refueling system give it a logistical edge no other spacecraft has. While Blue Origin's path is more incremental and cautious, SpaceX is trying to rewrite the rules, turning lunar exploration from rare, one-off missions into regular, cost-efficient operations. If NASA truly wants a lasting lunar presence, a base, a science hub, maybe even a stepping stone to Mars, then Starship is the most practical, powerful option on the table. Its ability to deliver astronauts, habitats, rovers, and tons of cargo in a single flight could completely redefine how humanity explores and lives beyond Earth.